Hello there, we're going to go over section 8.1, perpendicular bisectors. So it's important for us to understand what we're talking about. So when we talk perpendicular, it means we're forming a 90-degree angle. So perpendicular means 90 degrees, and bisect means to cut in half. So in a triangle, we're going to look at a couple of different rules that we could see show up in triangles. And so triangles are pretty unique, and as we go through them, we're going to spend some time looking at different lines that we can use in them. So the first one we talk about is the perpendicular bisectors. So here we're talking about these lines right here. Okay, these three lines, they're perpendicular. They form a 90-degree angle, as we can see. So we see a 90-degree angle here, a 90-degree angle here, and a 90-degree angle here. And then we also see that these lines bisect, so they cut these sides in half as we go through it. So we bisect them here. So we have these perpendicular bisectors. So then once we go from there, so we have these perpendicular bisectors, our rule says that from where all these perpendicular bisectors meet, we have this point P right there in the middle. From that point to each vertex angle, so from P to B, P to A, and P to C, that these are all these sides are congruent, or all these are congruent. So this is the same as this, which is the same as this. They're all the same. So if one were 20 inches, 20 units, 20 centimeters, whatever it may be, then all of those would be 20 as well. So we're going to use this, okay? If we have perpendicular bisectors, where they meet, where those bisectors meet, okay, then the distance from that point will give us our congruent. The other thing is up here I want to just show you where three or more lines are concurrent, they intersect at the same point. So this would be a point of concurrency where these 3 points meet. So we're going to be looking at different types of points of concurrency. So when we come down here, it says, all right, given ZM is 7, so Z to M is 7, so this side right here is 7. Given Z to J is 25, and then H to K is 20. Now, one thing that I would go through, and I would just fill out some things. So these are perpendicular bisectors. It tells you this one, and this one. KZ, LZ, MZ are perpendicular bisectors. So I know if this side's 20, this side right here is going to be 20 as well. Okay. The other thing is, since they're perpendicular bisectors, where they meet, this point of concurrency, we just said that the distance from that point to each vertex point will be the same. So H to Z is 25, and H to G, or Z to G is 25 as well. So then it says, okay, find Z to H. So Z to H, we'll use blue. Z to H is right here. From Z to H is that line. And we said, hey, that's from the point of concurrency to the vertex. So that's going to be, so we'd say Z to H is going to be 25. Then it says H to G. H all the way to G. Well, remember we said this side was 20, and K to Z is a perpendicular bisector, so the other side is 20, so 20 plus 20 is 40. So H to G would be 40. Okay, now we're going to start all over. Okay, we're going to erase all this for B. And we go through B and we say, okay, now we have Z to H is 85. Again, I would go ahead, okay, and it says M to Z is 13, so M to Z is 13. And then we have H to G is 136, so H to G is 136. Then it says, okay, now again, I would fill some of these things in. So if I know that this is 85, then this has to be 85, okay? And this is 13, so I can't do anything there. So then we go from there. Just remember that this is bisected. This is cut into 2 equal parts. So we go through it. So if we want to find K to G, K to G is from this point to this point. So we know the whole distance is 136. So then we just take our 136 and we can go from there. So we take our 136, divide it by 2, and we get 68. So this side right here is 68. So we know K to G equals 68. And then we want to find z to j. Z to j is 85, because remember from the point of concurrency to the vertex that they're going to be the same. So this would be 85 here. Okay, now I just want to go through, find one more, m to j. So I want to say, okay, what is this side down? Let's go this one. What's this side right down here? Okay, well, if you look at it, so right here, I want to point out that we have a right triangle. So this right triangle, so I'll draw it down here. This is the one I'm talking about. This right triangle has this side being 13. We want to know this side down here, and this side's 85. So we're going to set up our Pythagorean theorem. We'll go 13 squared plus, and you could say the question mark squared, equals 85 squared. So that's 169 plus our question mark squared equals 85 squared is equal to 7,225. So then we subtract the 169. And so we get here, squared equals 7,056. So then from there, we have to take the square root of it. And the square root of 7,056 is 84. So this side right here, okay, m to j would be 84. So we could also answer and say this side would be 84. We could say g, so then we could find g to j, and we could go from there. So that's just to point that out to you. Now, these ones are the same, so you guys can go through these ones and practice these ones here. So then down here, we want to go ahead and graph the triangle with the vertices that find the circumcenter. The circumcenter is where our perpendicular bisectors meet. So if I have -6, 0, I have 0, 0, I have 4, 0, or 0, 4, I connect all of them, and we want to find, there we go, the perpendicular bisector of two of the sides. Well, this is pretty easy to find perpendicular bisector. So first bisect. This side is 1, 2, 3, 4 units. So half of 4 to bisect would put me right here in the middle. This line right here, okay, this line right here, that red line, okay, is a vertical line. So to find the perpendicular to 90 degree from a horizontal line is a vertical line. So it'd be right through here. That's the perpendicular bisector. So then we go down to this line down here, and we say, hey, that's a horizontal line. It's 1, 2, 3, 4, 5, 6 units long. So half of 6 would be 3. So I just count 1, 2, 3. And now we draw our line through there. And where those two lines meet is right there. So that would be at -3, +2 is the circumcenter. What that means is that's the center of the circle that would circumscribe, that would go around it. So if you took your compass and you opened your compass and you went from that point where those meet and you opened it to the vertex and you drew a line, or you drew a circle around it. So once again, you line it up. All right, it's not wanting to do it for me right now. There we go. You can kind of see it as I go through. So there's my, had my circle going. So, it's going to do it again. Okay, but you can see, you can kind of see that circle emerge. You can see it go all the way around. It touches each vertex, and that's it as you go from it. So if we did the same one, same thing, so -1, 5. So -1, 5, put our point there. 5, 5, put our point there. And then 5, -1. Once again, we're going to have triangle. And we want to find the perpendicular bisector. So again, I could find the perpendicular bisector of 3 of those sides, I only need 2 of them because I only need 2 lines to intersect. And I'm just going to find it of this horizontal line and the vertical line. So once again, I'm going to find of those 2 sides. I count 1, 2, 3, 4, 5, 6. So half of 6 is 3. So I go 1, 2, 3. So right in this line, that's going to be one of them. Same thing here, 1, 2, 3, 4, 5, 6. So I go half of that is 1, 2, 3. Draw my line. So right there, that is the circumcenter. So that would be at 2, 2. And then again, what that means is if I were to open my compass, and use my draw a circle, you could see it going around, and it touches at those vertex points. So there, that's a bare circle. So that right there, we see the circle touches all the vertices, and it goes all the way around that triangle. Triangle fits inside. So that would be the circumcenter of it. So that's what we'd be going through as we look at it, looking at perpendicular bisectors and then how to find the circumcenter of a triangle.